Hello folks and welcome back to the channel. This is the second problem in the series on heaps, and today we'll be discussing Leetcode problem 767 reorganize string. So let's quickly go through the problem first. The problem statement states that given a string S, rearrange the characters of S so that any two adjacent characters are not the same, and return any possible rearrangement of S or return empty string if not possible. So basically we are given a string of characters and we need to rearrange the permutation of this string where no two adjacent characters are same, and if it is not at all possible to find any such permutation, then we need to return an empty string. So one thing that is very clear from this problem statement is that the arrangement of letters in the initial string is of no significance for us. So for instance, string ABA, AAB and BAA are actually same for us. So the initial organization or the arrangement of letters in the string is actually of no significance. And if the arrangement of the letters is of no significance, the only thing which is left is the frequency of each letter. So let's try to understand that how we are going to use the frequency of each letter to actually solve this problem. And let's take a bigger example. So let's take a larger string A B B A B C D C. So let's try to find out the frequency for each letter. So the frequency of A is 4, frequency of B is 3, frequency of C is 2, and frequency of D is 1. Now once we have identified the frequency of each letter, our final task is that we need to place each letter in the answer string or in the final string, and we need to come up with the permutation or a string where no two adjacent elements are same. So to come up with a string where no two adjacent elements are same, we can use a simple technique where whenever we place a alphabet, along with it we place another alphabet which belongs to a different group. So if we are placing two alphabets at a time in the string, we can make sure that two similar alphabets or two same characters are not adjacent to each other, because we are specifically or explicitly placing two different characters every time in our final string. So for instance, if I pick a letter from the group C, then along with C, I will place a letter from one of the groups like A, B and D. And by doing that, I've ensured that whatever next character I pick or place are never same. Now, if we actually see, what we are trying to do here is that we are picking elements one by one and we are trying to exhaust each element. And to exhaust a character from one of the groups, we also need a character from the other group, because we are placing two characters at a time. Now that we have figured out our technique for placing characters in the final string, the only thing left to find out is that in what order are we going to pick up these groups, or in what order are we going to exhaust these groups, because that is going to matter a lot in our answer. So here actually we follow a greedy approach and we always pick two groups which have the highest current frequency. Now this logic can be understood in two ways. So first is an intuitive explanation. So the intuition says that we are trying to exhaust groups one by one. But if the smaller groups exhaust themselves, then towards the end we might not be left with any other group to exhaust the larger group, and then we would have no option but to place all the characters of that larger group together, giving us same characters adjacent to each other. So it makes sense to first exhaust the larger group so that we are not left with elements from the same group towards the end. And we can also understand this using an example. So the second way is taking an example and trying to see that what happens. So let's assume that we are not picking the groups with the highest frequency at every step, but what we are doing is we are randomly picking groups. So let's assume that first we have picked B and C. So if we have picked B and C, always we'll place BC, BC. Then there will be one character left in the group B. We have already exhausted our C group. Now we place B and let's say we pick up D group. So now we have also exhausted the B group and the D group. Now we are left with four characters which belong to the A group, and we have no choice but to put all the characters together because we do not have any other group left to exhaust A. So that's the reason it makes sense to pick the largest groups first. So let's try to use the strategy and see that if that strategy works on this particular example. So as we said that we'll try to pick up the largest group first. So if we try to pick up the largest group at every step, right now the frequency of A and B are the largest. So we'll pick A and B and put it in our string. So this frequency will reduce to 3, this frequency will now reduce to 2. So now we again pick up the groups with the largest frequency. One is obviously going to be A. The second, we can pick any group in case when the frequencies are same. So let's say we pick up C. So we'll place A and C there. So this frequency reduces to 2 and this frequency reduces to 1. Again we are going to pick A and B. So again this is going to reduce to 1, this is going to reduce to 1. Now once when we have same frequencies, we can pick any two groups. So let's say we picked A and D. So we placed A and D here. These two groups have been completely exhausted. The only two remaining groups are B and C. So we'll pick B and C, and we can see that using this strategy, we actually came up with a string which is in accordance to the constraints given in the question. So this is a greedy approach actually, because at every step we are picking the groups with the highest frequency, and we are using the heap data structure to efficiently get the two groups with the highest frequency at every step. So let's quickly go through the code for this solution. First, as we discussed, that we need to get the frequency for each distinct character present in the string. So we have prepared, so we are storing the frequency in a vector of size 26. So we know that it is given in the question that the string contains only lowercase alphabets, so there are going to be 26 possibilities. So the index in the vector is actually representing the alphabet. So 0th index represents A and 25th index represents Z. So we are picking characters one by one, and then we are doing a plus plus in the frequency. So each cell is actually storing the frequency for that character. Now we are pushing each character with its frequency in the heap. So here we are using a max heap because we always want the two highest because we always want two groups with the highest frequency at every point. So in the heap we are actually putting a pair of frequency comma character because we want the comparison in heap to happen on the basis of frequency. So we are making it the first member of the pair, and we also need to keep track of the character being represented by this node. So we are actually storing a pair, but the first member again is frequency because always the comparison happens on the basis of the first member of the pair. So once we are done creating the max heap, we come to our actual logic where we create a final answer string. So in this logic, so let's assume that more than two groups are left in our heap. So if more than two groups are left in our heap, what we do is that we get the two groups with the highest frequency. So for this is so in this step we get the group with the highest frequency. So in the first part we are actually storing the frequency, and in the second part we are storing the actual character, and then we remove this root. Now once we have removed this root, the new root would be this group with the second highest frequency. So we also get this group with the second highest frequency. Again we get the frequency and the character itself and remove the second group as well. Now once we have removed these two groups from the heap, we know that these were the groups with the two highest frequency. So we'll add these characters to our answer string, and we'll reduce the frequency by 1 because we have used one characters from each group. So the frequency of each group reduces by 1. And then if there are any more elements left in this group, we'll again add it to our heap for further computation. So if the group has been exhausted, then we do not need to add it again to the heap, but if we are not done, so we'll add it to the heap again. So this is the general procedure which keeps going on. But in the case when there's only one group left, so let's say that there were A, B, C, and we have completely utilized B and C, and only A group is left now. So if in the case when only one group is left, we first take the frequency of that group and the character in that group. Now if the frequency of that group is greater than 2, so there's absolutely no way in which we can place these two characters in the string and they are not adjacent because all other groups have been exhausted, so the remaining two characters are actually going to come together. So if the frequency of the remaining group is greater than 1, then there's no rearrangement possible and we return an empty string as directed in the question. If the frequency is only 1, only one character is there, we simply add it to our string and we return our string, our final answer string. Now let's try to analyze the time complexity of the solution. The number of elements that are going to be in our heap is going to be equal to the total number of distinct characters which were there in our input string. So in the worst case, how many distinct characters can be there? In the worst case, they are going to be n distinct characters. And in the case where there are n distinct characters, this bigger loop or the main logic is going to run n times. And in every iteration, we are calling the extract or delete method on our heap. So as we know that on a size n heap, the extract or delete method takes log n time, and we are doing this operation again and again n times. So the total time complexity for this solution is going to be big O of n log n, where log n is the time complexity for extract method, and we are doing this extract method n times. So I hope you have understood the logic behind this problem and also how and why we have used heap in this problem. In case you still have any doubts, please feel free to drop it in the comment section and I'll address it there. And in the next video, we're going to discuss another problem on heaps. So see you in the next video. Till then, take care. Bye bye.